In D, you first would recognize the ether. It's written out a little strangely there, but that's the oxygen. The ET that's on the other side, that's standing for an ethyl group. And an ethyl group is where you have a CH2 and then a CH3. Or if you prefer the skeletal structure, it would look something like that. So that's an ethyl group, and that means that there are only 2 carbons on that side, 1 and 2, whereas on the other side we have 1, 2, 3, 4, 5, 6, and so our backbone is definitely going to be that ring on the left. So that's the backbone. The backbone on the right only, or the carbon chain on the right only has 2 carbons, so it's smaller. And our first step would be to name that backbone, as if there were no branches on it. So we said there were 6 carbons in it, 1, 2, 3, 4, 5, and 6. The prefix for 6 carbons is hex. In that chain, there are only single bonds. All those bonds there are single, and when you have all single bonds, the infix is AN. And the suffix. Now the suffix is, if you look at the rest of this, we actually do have a functional group. This functional group here, this OH here, is an alcohol. And so the suffix for the molecule is going to be OL, hexanol. There's one other thing. This 6-carbon backbone is in a ring, going in a ring. And if you ever have a ring, you put cyclo in front of the name to show that it's a ring. So our backbone here, and let me just adjust it so that it has the functional group in it. The backbone is going to be cyclohexanol. That's this right here. Cyclohexanol. Now that we have the backbone, let's see if we can name this branch right here. We have the ethyl group, so 2 carbons, prefix is F, and then as we've seen before, you have that oxygen. That's oxy, so the name for that branch will be ethoxy. So we have our ethoxy branch. Now, when you're numbering this ring, you would start at the functional group that's represented in the suffix, so that's going to be 1, and then we'll get the lower number for the ethoxy group if we go clockwise. So this is actually 2-ethoxy. So we can take that 2-ethoxy, put it in front of the backbone name. Right now, what we have for the name of this molecule is 2-ethoxy cyclohexanol. And the only thing is that one thing that should stand out here when you're looking at this is that you have that solid wedge, or that dashed wedge, which we've seen in the previous part of this problem, in exercise 1. And those are the stereochemistry. So those are the solid wedge here at the top is telling you that atom, that group, is coming out at you. This dashed wedge here is telling you that the ethoxy group is going away from you. And they usually include those because you have chiral centers there. So let's see if you do have chiral centers. Now you identify chiral centers first because they have to be bonded to 4 different things. This is the atom that might be chiral because it has this solid wedge there. And so let's see if we can identify 4 different things attached to that atom. We have the OH for sure. We have the carbon ring with an ethoxy really close. Okay, that's the second thing. We have the carbon ring with the ethoxy really far. That's a third thing. And last but not least, let me get rid of this here. So we got carbon ring without the ethoxy group, or the ethoxy group far, that's a third thing. And the fourth thing is a little hidden. Remember that if you ever have a tetrahedral carbon, a carbon with all single bonds, you'll have 2 in the plane, one bond coming out at you and 1 bond going away. And so going away here is going to be a hydrogen. That's the only group that wouldn't have to be written in. That could be sort of implied and invisible. Okay, so we do have 4 different groups here. So this is a chiral center. And when you have a chiral center, you follow the Kohn-Ingold-Prelog, or CIP, Kohn-Ingold-Prelog rules, to determine whether it is a right-handed version of the molecule or a left-handed version of the molecule. So right would be R and left would be S. And this is important because those two versions of the molecule fit into pockets differently, just like a right and left hand fit into gloves differently. So the first step is to look at the 4 things on that chiral center and prioritize them. And you're going to prioritize them based on atomic number. So we have a carbon here. And if you look at the atomic number, that would be 6. We have a carbon here. If you look at the atomic number for that, that would be 6. We have an oxygen. Oops. We have an oxygen up top. If you look at the atomic number for that, that would be 8. 8. And we have a hydrogen. The atomic number for hydrogen is just 1. And so those are our 4 things. And you can see that the highest atomic number is 8 for the oxygen, so oxygen gets the highest priority, number 1. The lowest atomic number is 1 for hydrogen, so hydrogen gets the lowest priority, 4. So we can erase those. Oops. And so it's just a tie between these 2 carbons. Now whenever you have a tie, you want to make a little table to help work out which one is ultimately higher priority. And we're going to list the 3 things, the 3 different things these tied atoms are bonded to. So this tied atom on the right is bonded to an oxygen and a carbon. This carbon here, this oxygen here, and also there's an implied hydrogen here. Now we put this in the table in descending atomic number. Oxygen has the highest atomic number, and then carbon, and then hydrogen. Okay. Whoa. So that is that carbon. Next. This carbon is bonded to one other carbon and 2 hydrogens. Notice I'm putting them in the table in descending atomic number, in order of descending atomic number. So when you compare these 2 tables, you compare one row at a time. Look at just the top row. Only if that row ties would you go to the second row down. You can see that the oxygen does not tie with the carbon. The oxygen has a higher priority. And so this right here would have a higher priority. Oops. That would be 2. And this would be 3. So the carbon chain that had the element with a higher atomic number gets a higher priority. In other words, the 2 rather than the 3. Okay. Oops. So those are our priorities. Once you have the priorities, make sure 4 is going away, and it is here. Once you know that 4 is going away, you can ignore 4. And you would go from 1 to 2 to 3. If it's clockwise, then it's R. And if it were counterclockwise, then it would be S. Now, we may have more than one chiral center here because we have more than one bond with stereochemistry. So it would be useful to say where we have this R. If you only have one chiral center, you can just put the R in parentheses in front of the molecule. But if you have more than one, then you have to say what atom that chiral center is on. So we numbered this so that the alcohol, the functional group represented in the suffix, gets the lower number. So this is 1R. We still put it in parentheses in the front. It's 1R. We just have to see if we have another chiral center, and if we do, we have to include that in the name. And the other chiral center, if we have it, would probably be right here, because that's where we have those dashed wedges. So let's see if that is bonded to 4 different things. We've got a part of the ring that doesn't have anything on it. That's one thing. We have a part of the ring that has the OH on it. That's a second thing. We have an ethoxy group. That's a third thing. And then invisible, coming out at us, would be hydrogen. That would be a fourth thing. And I know it's coming out at us because you have two bonds in the plane, one going away from you and one coming out at you. So, we do have four things, and this is a chiral center, so we have to say whether it's the right hand or the left hand version of this atom. Okay, first step is to assign priorities. If you, we already saw in the last one, oxygen has an atomic number of 8, and so that gets the highest priority here. Hydrogen has an atomic number of 1, so that's the lowest. We have two carbons that tie, so this carbon here and this carbon here, they both have an atomic number of 6. And so whenever they tie, you make little tables. So this top carbon is bonded to an oxygen, a carbon, and a hydrogen. Put those in descending atomic number, in order of descending atomic number. The carbon at the bottom is bonded to a carbon and two hydrogens. Put those in order of descending atomic number. And when you compare the tables, look one row at a time. We're looking at that oxygen and the carbon. Oxygen has a higher atomic number than carbon, and so this top carbon bonded to that oxygen is a higher priority. So that gets 2, and the other carbon will get a 3. So we go from 1. Oh, okay, we've assigned priorities. The second step is to make sure that 4 is going away, but here 4 is not going away. 4 is coming out at you. It's pointing toward you. And whenever that happens, you still go from 1 to 2 to 3, see whether it's clockwise or counterclockwise, and assign R and S based on that. Just after you get that assignment, flip it. So for example, here we go from 1 to 2 to 3. That is counterclockwise, and counterclockwise would usually be an S. But the fourth thing is coming out at us. So you flip it and it's actually R. That's the rule for that. So this is going to be R, and we saw the numbering before. The numbering is 1, 2, 3, 4, 5, 6. That gives us our lowest number for the ethoxy branch. We have to start numbering at the functional group there, the alcohol. So this is 2. This R is on 2. So this is going to be 1R, 2R. There's both of our chiral centers represented in the name. So the beautiful lyrical name for this whole molecule is going to be 1R2R2-ethoxycyclohexanol.